Okay, it's it's a noontime. Okay, Central Time noontime. My Pacific time 10 o'clock in the morning. So anyway, we are only about 2 weeks left. Okay, not less than 2 weeks actually. And number one thing I would like to remind still be the due date. Okay, the final due date is December 17. Okay, I'm sorry. The 11:59 p.m. Okay, before midnight. Okay, this just means that past midnight we don't accept anything. Okay, it's already 2 days past the class, so 17. Okay, 17 is a Sunday, and on Tuesday morning 8 p.m. I was required to submit everything, all the scores. So I usually use the Monday to do the final tabulation. Okay, so help me to finish everything. So if you miss this time, I'm 200% sure I'm not going to take it. Okay. But anything you submit before this time will be graded, and I don't give you a deduction because it's an 8-week course. I will give you the maximum flexibility to work on the homework. Okay. So basically, don't miss this time. Okay. Whatever you want to submit, you need to submit before it. Okay. Try your best. Okay, number two, actually, let me see. Number two, actually, still, there are still students who actually never follow the rule that we have, okay? So we do announce many times that our requirement for the term project and proposal, right? The proposal, we say that it actually is for you to prepare the proposal when you actually work in a company, right? You need to work on proposal and then submit to your manager to request for a project. So that's something we want you to practice on and then learn the format. Okay, learn the format. What should be the deliverable? What should be the schedule you want to propose? What are the costs, the tools that you want to use, and also the environment, the programming environment that you want to set up. Okay, so that is the purpose of proposal. But the purpose of proposal, the topic itself, as long as it's related to robotics, it will be acceptable. Okay. But still, students still asking question that can I actually validate or approve their proposal? Okay, I don't do that before you submit. Okay, I never do that before you submit. Proposal is your own proposal to your boss, right? So if you don't have competence on your proposal, you don't submit, right? And you cannot win the project budget. So that's something you need to learn the format and also learn the thinking process and also learn the whole organization of the proposal, right? Putting what ingredient into there. So that's the purpose of that. And then if your final term project's topic is different from proposal, that's acceptable, right? You propose something and in the middle, you believe that you don't have time to finish everything. You believe that you don't have the budget to finish it, or you think that something is more interesting. That's essentially acceptable. So these two things we will be evaluating separately. Okay, so don't put your proposal in your term project. We don't need that. Okay, we don't need that. Term project, just submit whatever related to your term project. Okay, this one is proposal is to asking money from your boss, your manager, right, or your VP to fund your project, or for some VC to fund your project. Term project is you present your final result. So this one, the main focus is what you have done. Okay, the key point is what you have done. So in the term project writing, do not give me a prior art history. Okay, it's okay to put some prior art history to talk about why am I doing this project. That's good. Okay, but do not just quote a lot of theory, copy from somewhere else, and then talking about what is robotics, and then the whole report is some other people's writing. Okay, I don't care about other people's writing about robotics. I only care about what you have done. Okay, that's a key point. You need to make the scene topic of your term project to remain on what you have done, right? So what you have done means that you need to include your tool, what's your thinking process of reaching the conduction of this term project. Okay, why are you doing in this way and not that way? Okay, so the term project portion, the written report portion is that you need to talk about why are you doing this project and why you pick a certain approach and not the other approach, and what you have done with this project and the references of your project. That's the written report. Okay, for the presentation, we don't need you to talk about the history or tool. So don't copy your Word file to PowerPoint. That's actually also another kind of value. Okay, we want you to focus on demonstrating the functionality of your project. So if you build a robot, just show me how your robot works and which part it doesn't work and because of why. Okay, you don't have time to implement it, or you believe that the parts are bad. Okay, that's okay. That's actually perfectly okay. We don't seek for perfection in the term project. Okay, and if you are doing modeling, you need to talk about what robot I'm modeling in. Okay, and then my program, how it works, and what is the visualization or the final presentation that you use your program to plot. Okay, and what kind of plot you have, and then what's the meaning on the plot. That's more like a data analytics or presentation, data visualization project. Okay, that's actually also fine. Just showing the program and how it works. Okay, do not include in your PowerPoint presentation with the whole history of why I'm not doing this, and then which paper talking about what. I don't care which paper is in you quote in the term project. Okay, this presentation, the PowerPoint part, just show what you have done and how it works. How it works is a keyword for the presentation. Okay, and the term project written report, you are welcome to put why you are doing it and the history. So these two writing are totally different. Okay, and why are we doing this term project with a unguided format? That's because that we want you to be able to do project independently. So unguided, no partner, we just do in this format. Okay, we don't do the project like other classes. Let's welcome people to do a team project and 3 partner, and usually somebody just sitting on the sideline, never participate working. Okay, and then just put name on the project. We don't have someone to do that. Okay, that's not what we do here. The purpose of this term project is really want you to really do something. Okay, either you build a robot, or you build up a mathematical model for robot, or you read some paper or read some article, and then presenting the brand new idea and talking about how this brand new idea would work. Okay, so if you work on the third idea that bring a new idea project, okay, your written report should including why you come up with this idea, and then why this idea is important. Okay, and describing that what is needed to complete this idea. Even though you do not build a robot, you do not build a mathematical model, but you need to tell about why you believe that if you done this, you will be able to build such a fancy robot, okay? And then you need to do feasibility study. What is the feasibility study? You need to prove this is doable, right? Okay, if say you need to do prediction. So right now we have a 3 nanometer IC performing a certain speed. You are predicting that if the semiconductor drop to 1 nanometer IC, the computing capacity will be how many times more than current capacity. So because of that, my project would be valid. So that is a good validation of your idea. So that will prove the feasibility. Okay. So in your term project presentation, okay, the write-up, you will include in all the reason and rules, right? In your write-up, you should include what? Because you presented your idea. So you need to just show your result for feasibility study. Feasibility study, okay? So for example, if you want to, let's assume this, okay? Let's assume that your term project for the new idea project is like, okay, I'm going to design a fancy car, okay? And then this fancy car will be a car, right, that will fly, okay? Okay, there are some people already did that, okay? And then you need to explain how you actually hiding your plane when you is in the highway mode, okay, highway mode. And then how you extend it, okay. And when it actually fly, okay, how much weight it need to be, and what kind of design you need to have, okay, and the power, what kind of power you need to have. So it is done this different item. Even though some of the engine not ready yet, okay, it's okay. You talk about current art, what kind of engine is available, but in how many years, and it may be possible. And then doing those kind of listing of feasibility study. Okay, even though none of them we can achieve it today, but you actually need to present that, okay, based on my study, how many years later or with what being invented, like superconductor being invented, then my project will be possible. Okay, so that's a future project design. But that's okay. We want you to create idea, and nowadays we are not short of engineering work, but we really sometimes short of the idea. Okay, the ideas. That's an idea project, okay? And you just need to prove the feasibility, and your presentation just need to show why you believe this flying car is possible and under what condition, okay? That's the last project. Okay, any questions so far?
No, sir, we are good.
Okay.
Thank you.
That's I go over the requirement for the project. Okay, again, final things that I need from you is a Word file or a PDF file. That's a final writing. In that one, you need to talk about why are you doing this project? Okay, what's the prior art? Well, how other people do, and your theory of doing this project. Okay, and why you take this approach and not taking the other approach, and also presenting some result in the document. Okay, that's your written report, the Word file or PDF. Second one, you may do a video presentation or a PowerPoint presentation. I'm fine either way. Okay, you put, if it's a video, you put on the YouTube or some other channel. Okay, and give me the link that can share to me. That's enough. Don't send me the MPEG file. Okay, that's too big for me. I don't need that file. I just need to you have the presentation of the YouTube. And if you also give me the PowerPoint, that's fine. Okay, one of them or both, welcome. Okay, but in this one, you don't need to put the history anymore. Okay, don't put the why am I doing this or I'm not doing that. Okay, I don't need that. Okay, that I can see it in your written report, right? So in the presentation, focus on how it works. Okay, just focus on how it works. The other part, we can see it in your written report. So this one, I just need to see how it works. So if you demonstrate your robot can run 300 miles per hour, okay, and then jump like 200 feet, I want to see that in your demonstration. That's it. That's all I need to see. Then you can prove your idea, your project is really working, okay? So there's a student who work on a toilet robot. Whenever someone finish the toilet in the restroom, then a music box would be activated and play music. And he showed me somehow very humble design. Okay, it's no boxes, no actually out exclosure, no nothing to cover the PC board or the IC or the activator and the sound track. Okay, whatever he just started cover everything, but it worked. Okay, that is already a very good project. I just need to see that your robot, if it's working and you're working on some condition, I want to see the working robot. That's it. I don't need you to put in your presentation about a lot of bullshit, talking about why am I doing this? Well, I don't need that, okay? That's something you need to put on the written report. That's the difference between the written report. Written report responsible for the why am I doing that, and talking about logistics and history, and then your achievement, and then your method, right? That's your written report. The presentation just focus on how it works. That's it. We don't need anything else. Okay. If you put some history, it's okay, but not too much. Okay. And then code. Okay. If you have some code that you develop, same as the source code. That one I don't judge too much, but I just want to make sure that that's something you really have done. Okay. It's just a proof of diligence, making sure that you really work on it by yourself, not something like, okay, borrow other people's term project from 2 years ago, okay, or getting some design that you have done 3 months ago in other events. That's not something we need, okay? We don't encourage that. Actually, we don't like it, okay? I want it to a project you have done purely and only for this course, okay? That's something we want to judge by the credit of the originality, okay, and authentic. And also, we don't want this project to have partner. The reason why we do that, because there are too many projects that are conducted by team, and we really don't know, this guy work on 30%, that guy 10%, this one even 0%, okay? So that cannot really grade on your effort, okay? And a lot of crowds do that, but I don't like it, okay? That's something we really don't want it to happen, because we want you to work on it by yourself, and you are able to manage everything by yourself. That's a key. And then we train students to be able to be a individual contributor, at least when you go to work, okay? When you go to work, that our purpose is that making sure you can be an individual contributor, that you don't need to. Individual contributor is the minimum level 2 engineer requirement, that you can work independently, okay? Level 1 in engineer is engineer under guidance, right? You need someone to guide you. Level 2 is engineer that you can work independently. Level 3 is engineer that can guide other people, okay? And with the AI's invention and the AI chatbot and a different kind of the AI technology be available, most of the level 1 and level 2 engineering position will be eliminated. And in the future, very few engineers will survive. They are all level 3. Level 3 engineer need to be work independently. They need to provide guidance for young engineers. Also need to be able to communicate with your boss, your manager. Usually these we call them lead engineers. And you need to train yourself to be ready for the lead engineer with good communication skill, with good leadership, with then you are safe in your job market, okay, in the job market. Nowadays, the level 1, level 2, very easy. You will be eliminated from your position, okay, because if they can find a robot to replace you, then you're out of the job, okay. So sometimes I actually describe it, okay. Nowadays, even the pilot, okay, your combat squad F-35, okay, pilot. Nowadays, F-35 may need to guide several F-18, okay, these are from Navy, or maybe from X-48, those drones, okay. So many of them actually being guided by single F-35. So this one is look like our lead engineer, level 3, okay. And everything else, very easy, they will be replaced by a drone, okay. So this will happen in our engineering world as well. There will be a lead engineer. He may guide some junior engineer, but those junior engineer must have the potential to be promoted to lead engineer in the future. Okay, and many GPT engineer. Okay, that means that GPT will be used as an engineer to generate code, but this guy need to be able to multiply their code and integrate everything together. Okay, we just need this kind of engineer. And those, if you are just a coder, I think that maybe 20 years later or 15 years later, it very likely pure coder would not be able to survive, especially if you become senior, okay? You will be required to have the capability to become a lead engineer, to be able to supervise some ChatGPT, okay, those kind of code GPT program. Also provide guidance for younger generation of the engineer, okay? This is required by the lead engineer of the future. If you are not able to do that, you cannot make proposal. You cannot work independently. Your job security will be very low, okay? That's why our term projects are formatted in that way. Even there is no guidance. I even don't actually provide you the topic. Okay, we just give you some possible topic direction, right? But if you ask me to provide you some specific guidance of, oh, can I do this project like this? I need to have a automatic soccer gatekeeper sensor, and that is a robot. It's so fancy. Can I do this project? Okay, sorry, I don't give you good or bad or any comment on those ideas. You need to come up with your own set of the persuading ideas, persuading point that this one is a good project. You need to win your boss agreement that your project can go, okay? And that's something you need to be able to done it by yourself. And this is a training to help you to become a lead engineer in the future. Is that okay? That's why our project is being organized in this way and not like other people's project in different classes. Okay?
Okay, sir.
Okay.
And no matter how bad you do, I will see at the end, we are good on it, okay? Don't worry, every student are the same, okay? We use the same standard to judge your project, okay?
Okay, sir.
And usually just like your homework, okay? If you are not copying, and also if your homework is actually working in the right direction, I usually don't deduct point, okay? I usually deduct point because you copy, or you actually totally don't know about what is going on for the project, then I deduct point, okay? Same thing for term project. Usually, I call this one, we are additive grading, okay? If you do good, sometimes you see that I get +5, +10, okay? If you do not, you totally don't know about your project, maybe -20, okay? You miss some homework, maybe -10. That's my grading way, okay? But I do not judge, okay, your number should be 3.14, but you give me 3.27, okay? I don't judge those kind of error. That can come from your engineering error, like calculation error or something, but that's not the key point, okay? As long as you are working on metric, and those metrics are in the right way, or miss a little bit, that's fine. We don't deduct too much over there, okay? This one is an 8-week work, 8-week course. We don't expect you to study an 8-week introductory to robotics and be perfect. That's impossible. I emphasize another time, the UC Berkeley's CS 106 A and B, there are 2 semesters, A, B semester. Each one of the 16 weeks. So they are 32 weeks, compare your 8 weeks, okay? So you cannot compare with some school that do that many hours, okay? We are only 8-week course. So 8-week course, the key point is that we go through every topic in robotics, making sure you understand what is here for modeling, what is robot building, what is metric, how I cannot use those metrics to do calculation. That's enough for 8-week student, okay? As for perfection, as if you are given more time, you will gain perfection and also gain more depth in the robot topics, okay? So I'm not aware of that. So after this course, if you like robotics or you like AI, you should continue to take more course or continue to read or study more, okay? Is that okay?
Yes, sir. Okay.
This is only an introductory course. We want you to know everything in the field, but not really deep, okay? We cannot do deep because of the time. We don't have the time, okay? And the project's purpose is to help you to really be able to perform well when you go into industry to work, okay? Sorry. And for those students, very rare case, those students, they are moving on to become working for PhD, okay? They are very few sometimes. I do see some students from Louis student, eventually they study for PhD program, okay? This course also give you some introductory study for the math that you require, okay? Even though we don't go into the real math training for it, but that's you will know what math you need, okay? You will know what math you need. That's the key purpose, okay? And then you know that what math you need to study them. That's even every branch of the math, that's a separate class. Same thing, every branch of the engineering work, like computer architecture, computer vision, right? Mechanical for the rotator, okay? Degree of freedom, the algebra, they are all different courses. So this course, in a way, putting it at a master level, is a summary course. It's a summary of whatever you have learned so far. And also it is an introductory course. So you know about the field of the robotics. And third purpose is that we prepare you to be able to manage your project in the future if you become a lead engineer. So do not think about something in the level 1 engineer thinking. I just need to learn coding. I don't need to learn listening, okay? That you limit yourself to a level 1 engineer. Just do coding, okay? And you need other people's guidance. Oh, I told me, what should I do this? What should I do that? Okay, that's level 1 engineer. You stay with level 1 engineer, then someday it's very easy. Google will cut you. Okay, even you go into Google or Facebook, they will cut you, right? Your value is low. That's why they cut you. Level 2 engineer, let me emphasize one more time, you need to be independently working on it. Okay. And that's still, some people still will cut you. Okay. And then if you are level 3, okay, you are able to guide people, you are able to propose your own idea, you are able to communicate with your management team, then your job security will be safer. Okay. You can become a PM, project manager, you can become a lead engineer, you can become a design manager, okay, in many ways. You can survive in more ways, okay? And of course, you can stay as an individual contributor. If you raise no management role, you can find, okay? So that's the direction you need to prepare yourself after a master degree, okay? That's why you differentiate yourself from a pure level 1 engineer that graduated from a bachelor degree from college. You got a master degree. You need to be a little bit different from those people, okay? And my requirement for some students who finish PhD, they should have the ability to start a new company, okay? If you study for PhD, you just want to become a professor. That actually is a loser in my mind, okay? Why are you spending so many years and then you just be able to guide some student to teach student in the university, right? That's not good enough. If you finish your PhD program, you should have the vision of where the industry should go. And you should be able to find a group of people that can finish the project with you. And you should be able to find some funding from VC, from investors, from angel investors, right? So that's the purpose for doing PhD. You spend 5 more years, not because you want to become a coder, right? If you spend 5 years in the PhD program, you become a level 1 engineer to do coding. What are you doing that? You can get your bachelor and you do it quite well, right? There's no meaning for doing that. Same thing for master degree. If you finish the master degree, your purpose is you want to become a lead engineer at least, right? You don't want to become a mediocre coder. That's not what you should do, okay? So anyway, these are actually some comments, and wish you be able to perform well, okay? Okay, let's go back to what we have so far. So a lot of our material is online. You need to spend time to study, okay? You need to spend time to study. I'm sorry, this was JavaScript. Let me close it, okay? Last week we work on the control, okay? So they are controlled with microprocessor, they are controlled with final state machine, they are controlled with different architecture, okay? You need to spend time to watch the video, okay? We don't have time to teach you everything in a short meeting, okay? Even 2 meetings is not enough, okay? Because there are so many material. So that's why I put a lot of video online for you to study, okay? Okay, and today we move on to this one called dynamic modeling, okay? If you are from the background of the EE, okay, you know what is control engineering, what is control, okay? Then this dynamic modeling will be easier for you. If you are coming from the computer science background, then you probably don't have the whole dynamic modeling background, okay? So this one is like, okay, we first set up the actuator, right? And this one control your robot arm, that's called manipulator, okay? That's your robot arm. So we talk about the theta versus the XYZ, the control variable, joint control variable, theta and the D, okay, versus that. And that's actually your workspace versus your control variable, okay? That portion is the first few chapter. We're working on that. And then we talk about the sensor, computer vision, how you sense your environment, build up the environment model, everything, right? And we talk about processor. Now, next one, we talk about the learning controller, the processor. Should it be sensory app? Should it be behavioral? Should it be training? Okay, different type. We talk about the 4 different type. Okay, these are done. So next topic is that this sensor provides some sensing for some X, and there are some planned value. X measured and X planned, and measure the difference. And then you provide a control box and use that to control your actuator. So you have the whole loop view now. Okay, you would have a whole loop now. So dynamic modeling's purpose is to build this whole, the model for this whole loop. Okay, the dynamic modeling is like this. And if you actually this controller over a planner is replaced by AI or machine learning, then we call it smart control. Okay, then we call it smart control. It's conceptually it's just this image. Okay, and as for how we do it, okay, there are a lot of story, a lot of theory behind. People generate a lot of theory in different domain. But at this moment, as an overall viewer, you just need to know about what is dynamic modeling and how can they help us in guiding my robot. Okay, that's all you need to know right now. Okay, so this chapter is providing the view for dynamic modeling. Okay, so we introduce what is dynamic modeling. Dynamic means that there is a change in the model. When there is a change in the model, you do have what? dydx. And since you have dydx and dt, these different things, change in time, change in value, change in independent variable, you will require differential equation. All right, so differential equation will be needed when you study this dynamic model, okay, because they are change intermediate. So that's what you need to know. This portion you need to have that. So you need to know about balance of equation, okay, how you get balance, because at the end, you want this system variable to be stable. So you will catch up from some location and then making sure it's stable. So your robot would actually perform and stop at certain time. So your environment keep changing, your planned value keep popping up with some value, but they will be tracked well by this loop that's called dynamic loop modeling. Okay, so you need to know about balance of equation. So in a system, there may be charge conservation, maybe mass conservation, maybe momentum conservation, all kind of conservation. Okay, as long as there is a conservation, that means there is a control loop that you can build upon. Okay, don't be afraid of these mass things. Okay, if you don't know math, you can still find some math expert to help you. Okay, but here you just know about the fundamental rule for the dynamic system is always the rule of conservation. Conservation. Okay, you need to be able to be have the conservation. So you set up there are several steps. Okay, so the following guidelines developing dynamic model. The process is iterative, so you need to go several times. And the simulation result will help you to build the model assumption and correct the error. Okay, so identify the objective for the simulation. What does this mean? This means that let's take the temperature thermometer monitor again. Okay, so there is a heater in the room, right? You need to heat up or heat up. And there's a sensor that's a thermometer sensor, okay, taking the temperature. And this temperature and your plane temperature, say you want to fix as a 68 degree F, but your temperature coming in is only 65. So in this case, you need to go up for your system variable to turn on the heater, right? And if your system actually is 85, so you need to drop, right? You need to drop. So these are the control, where the control come from, okay? And you have the temperature conservation you want to do, okay? So basically, you need to identify the objective. So the objective right here for the temperature sensor would be a objective temperature. Okay, you want to control your heater so that the room temperature will stay with the temperature plane. Okay, so when you have AI or smart monitor, that means that the 24-hour you already set up a historical temperature pattern. So for example, in the morning, you need to turn down the heater more. In the room time, you do less, so that you already have a learn curve. Okay, the learn curve is based on history of the usage. So you have new usage record. So the homeowner set up in the morning 5 a.m. to 70 degrees degree F, right? And then the noontime turn off. So these are some past pattern. And if you put it into the learning system, right? And your machine learning will learn this. And then what? And then your sensor become a smart sensor, okay? And if you just set up a goal, 68 degrees F, and they don't have history, you just set up that and within the loop to finish it. That's a regular loop, regular controller, okay? Robots sometimes use a regular controller. It may not be intelligent. It may not be smart, okay? Depending on your budget and your usage condition, okay? You may not be smart. So after you're doing that, the second one, you need to draw schematic. So schematic including the temperature variable, control variable, and also the actuators available, SCADA, D, okay, whatever, okay. And list down all the assumption and set up a differential equation that can create a dynamic balance. That's it. Okay, this is the whole thing you want to do for balance. Okay, and other things like water tank balance. Okay, whatever. These are different examples. And then they will have different dynamic balance equation. Okay, so this one is to maintain. There's some flow out, there's some infill. You need to maintain some water level. So that actually is a dynamic equation. Okay, but anyway, this one are involving math. We already have the equation, so I don't spend time to explain every line of the code. Okay, so the Python simple model water.py you can download from our course. Okay. And you can set up the ODE equation and then transform it to the Laplace transform, the transform domain, okay? And then you can solve the equation faster. And then your input is like this, your control function is like this, your output is like this. That's the simulation. When you have a change on your infill level, there will be a reaction time to catch up. Okay, this is a control function for infield. Okay, so that solve the equation for you. So that's why we have the ODE to solve the equation. Okay, this you need to study. So there's solving with ODEINT. Okay, what this function really is. ODE is ordinary differential equation. INT is integral. Okay, so there's a function called ODEINT in our Python. Okay, it's in the package called Gecko. Okay, there's a package called Gecko. Okay, so for Gecko, if you don't have Gecko, in a way, you need to know about some differential equation, okay, before you use it. So if you want to do Python Gecko, okay, Python Gecko, the Gecko optimization suite. Okay, I think TensorFlow or something else also have optimization, but it's a Gecko is purely for so if you want to install, it's a pip install Gecko. Okay, you will get this Gecko package. It's for optimization, so linear programming, quadratic programming, nonlinear programming, mixed integer programming, all kind of the optimization scheme are here. Okay, Gecko is a big package. If you do optimization, you need that. Okay. By the way, there are two important math courses. If you do AI or machine learning, there are two important courses. One is called machine learning. I'm sorry. Let me talk about machine learning later. Two important math courses you need to take. One is called optimization. The other one is called random process. Okay. So this Gecko is solving this optimization problems. And our loop control dynamic system is just a lot of integral and differential equations, so all related to optimization. So this Gecko package is something you need to know and you need to learn. Okay. So these two courses and also linear algebra, also multivariable calculus, also principal component analysis. This is from stats. These different courses will be the ingredient before you learn machine learning. Okay, you must know this. The whole machine learning is an optimization engine. Okay, so machine learning, this optimization course is more important than random process. The core ML system is an optimization system. The random process is used to model the input and output. So what is process? Okay, you have a variable, right? You have a variable that's called X, right? You have random variable. Random variable is X with a certain probability distribution. Okay. And then you have function. So a single variable is a point of data. A function is like this. It's several data over the time. Okay. That's called function. And what is process? Process is a function over the time with probability. So it's a probability of a function over time. That's called process. And our real world signal, speech signal or image signal, they are all random process coming into an optimization system. And you base on the incoming random process to do optimal optimization. Then that become your pattern recognition or become your character recognition. So that's how the whole machine learning works. Okay, that's how the whole machine learning works. Is that okay so far?
Yes.
So this is a side talk, okay? Why we are learning this Gecko package, okay? It's core for the machine learning. You should, and you, if you like machine learning, you must have it, okay? You must have it. And this is in the Gecko system, you solve the this differential equation. So I don't go into the detail, okay? Same thing, this one solve the differential. It's decay down, so this is integral with negative value, okay? Integral with decaying value, so that's that, okay? You have different slope, different k value, you would have that, okay? So this is solving a simple ODE3, okay? This equation like this. You will solve the equation, you get this, okay? This part is only math, just teach you how to do the ODE integration. Then you have balance equation, okay? Balance equation, you model some mass balance or whatever. Mass balance can be used for the water flow, right? The water flow is a mass balance. And the species balance, if you are doing biological study, okay? Some animal die, some animal actually being generated. So rabbit, okay, there's a consumer producer model in the ecosystem. If you have a rabbit and a wolf that will eat that rabbit, right? That's a species balance equation. Momentum balance, okay, this actually other balance, I don't go into there, all kind of balance that you have, okay? And balance equation, you kind of come with the equation. So this is a balance equation. Our robot control is a balance of system variable, right? To be short, our robot control is balance of the system variable. We want the temperature to be controlled to a certain temperature, right? That's actually our goal. So that is also another balance, okay, the temperature. Other than that, I don't actually, here are more typical math derivation and modeling and more Python code. You download from the website, okay? I have the code. You can look at how these different math go, okay? I don't spend my time here to do it and also do plotting, okay? So in a way, why we pick the Python as the main language for our robotic course, just because Python is the best language for AI. Python is the best language for data visualization. Okay, you cannot find another language that can do a good job. Okay, there are some good ones coming up, but still not as good as it. Okay, but once you want to do acceleration, so far we teach you the PyLab, right? There's a Python, you do PyLab, right? And then there is Python Matplotlib, right? These are something I recommend you to do so far, right? These are basic programming. If you do programming using Python and model, it's good, but this is not enough. That's not fast enough. So if you want to do fast data presentation, there's a C++ Matplotlib. There's a package for C++ Matplotlib. Okay, you can download somewhere. Same idea as Python, okay, but you will provide you the acceleration. You see, it's a chart is very familiar, right? Is that okay? Once your program is too slow, you need acceleration. Yes. This C Matplotlib, okay, same name as our Python. These are all free. Okay, there's some people even have a Matplotlib 17. Okay, for C++ 17, you need to download this one. Okay. Then the same package that you learn from Python can still be used. Okay. And C++ has another advantage. Python is toy language, okay? Python by itself is a toy language. C++, once you finish the C++, you can move on to system C or system C++, or moving on to Verilog. So this different language is the hardware modeling language. Okay, so that's the path that you develop hardware. Okay, in the past, actually, I work on Ethernet. Okay, 1 gigahertz Ethernet chip design. We all starting from Python model. I'm not using Python. I'm using MATLAB. Okay, so MATLAB is similar to PyLab. Okay, so I use MATLAB and then using C language and then model the whole hardware and then release the design. Okay, that's the path that I use for modeling of my DSP project. Okay, digital signal processing project. So anyway, these are different solutions. Okay, more equation. Okay, so and if you are not able to solve the differential equation, you need to use a Laplace transform. Okay, so here we also include a Laplace transforms table and how it help you to solve the differential equation in the S domain. Okay, and also performing Laplace transform in Python. Okay, and also perform the time delay problem. Okay, so a lot of math and theory and transfer function. Okay, and you want to solve the transfer function. Okay, transfer function. Transfer function is the box that you realize the control box. Okay, but anyway, tons of math. Okay, I just give you the material. We do not have time to teach this, right? As I say, this one, each section may take 1 hour, 2 hours. Okay, I'm speeding by, but each one of these will take 1 hour, 2 hours. So you can download our material to your local, okay, even video, okay. Usually my student, if I have my own website, I provide them the lifetime access to our website, okay. But Louis' course did not provide that, okay. So you can find a video from my video. If you want to keep them, the video, you can go to. I'm sorry. You can go to YouTube, okay, and then search for Dr. Eric Chow and then Louis University. Okay, this one. Okay, you will find this one. And then there are many playlists. Okay, one of them is this CS65 robotics. So whatever video that in our course, you should be able to find it here. So after you taking this course, many years later, if you still need them, well, this one too short. Okay. No, not this. This one is only the headers, the term project part. There's another one. Let me see. Okay, I think this one. Okay, this is recorded 21. This one is the complete one. So every chapter we do go over it, the video. Okay, I think you will see this one, and I also put some students' term project here. Okay.
Okay, here is
this is the one I talk about, the toilet robot. Okay.
Robot.
So whatever, let's see the low the final part. Sorry.
And so that's really maybe give.
Let me see. There's a part that he do the experiment. I'm sorry. Okay. So here, this one,
This music is
there's a
going to
music,
play.
okay, there's a ball, and there is a
this
sensor.
servo down
Okay.
here is going to engage and set its position to 0 degrees. And so the reason for all of that is just because I want to know that my robot is in the state that I want it to be before I give it any commands. And so once it exits that state and plays the music, it's going to shift to the ready state, and this green light is going to start blinking green to show that it's ready to go. So what we're going to do is we're going to plug it in. Plug it in. So we have servo move, lights, music. Okay, so it's now in the ready state. We can see that by the blinking green button. And so down here is our ultrasonic.
Okay, so this is some students' project. There's another one. Okay, this guy just show me how he assemble everything. So he record down. Okay, that's good. Okay, that's good. I don't need you to see you are give me a lot of theory. Okay, I don't care. Okay, I don't care that your grandpa happened something. That's not something I need to know. Okay, I just need to know how you work on it. Even no theory, this guy just really show me every minute of the robot building. You see, this guy keep recording whatever his progress is. This is what we need, hand-on engineer, right? And then solve the problem by himself. So you see, the whole video is he keep assembling the robot and then doing programming by himself. Right? You see, this guy, whatever he did, he tried to do it right by himself, and it's moving. No matter how good it moves, I don't care. It's using the Android to Arduino. I'm sorry, Arduino to control it. You see, this is a perfect project. Even though the code may be copied from somewhere, I don't care. This guy, at least he's doing everything from scratch, all by himself, right? This is a good project. So usually some project like this, if the full score is 700, I may give him 800. Okay, so this is a good project. Okay.
Good news. We have.
This is a good project, and we encourage that. Okay. There's no need to talk about a lot of the unrelated words. Okay. So this every year we have a recorded session. Okay, that's this one. Let me find some older one. Okay. Some older one, 2021. This one is original one. Let me see. 2022. Oh, this is not robotics. Let me look at the playlist. Okay, I'm sorry. So here, let me see. There's another year. Okay, let me see. 23. There's a 22 missing. Okay. Okay. Anyway, I cannot find it here. Okay. Let me try to do. Sorry. Let me try to look at video. Okay, these have all of the video for programming language and robotics being done here. Okay. I have the 2022 version. Okay. But anyway, I cannot find it right now. Okay. Maybe because I do not put them as a public, so right now you cannot find it. Okay. But our course image do have every year's recording. Okay. So you should look at them. Okay. You should look at them. Let me pick up the course image. So remember here we do have week 8. After week 8 is a recorded session. Okay. So this recorded session we had the 2020, 21, 22, 23. So I think the most complete video is this 2021. Okay. If you want to look at the course recording, The one that we use for teaching is this version. Okay, and then there are also some robotics in this 2020. Okay, let me pick something that's actually this one. This is also a 10 project. So it's trying to build a robot and operate it in, okay. Okay. Do not need to have too advanced motion. Okay, just something you can control, showing you are controlling. Okay, and then he also present his way of control and program in a different part. Okay, that this is a project, good project. And let's see this one. Another robot building project. Let's move a little bit faster. Okay. He's just showing me that what component he got. Okay, and then get started. Okay, so this is a good building project as well. Okay, no matter eventually his project work or not, I just need to see that he goes through the whole building process. Okay, we don't have lab, so we cannot actually teach you how to do robot building, but we do wish student, if possible, with some budget, maybe $300 or something, right? Build a robot of the lifetime for yourself, okay? So this one, whatever. Eventually, how it work, bad or good or bad, at least he's trying to demonstrate, okay? That's good enough. And the programming task will not be finished only by the 10 project, okay? There's more thing to be done, you see, okay? Okay, so this is also a good 10 project, okay? I do not require everyone to actually build a robot. Some of them do modeling, okay? Some of them do this car assembly. Okay, just show me how it works, okay? You can see that this car is short-sighted, okay? Cannot see too far, so you have to use a paper to guide it in front of it. That's also fine, okay? We are not building the perfect robot, okay? Just something you able to do, okay? Any question so far?
No.
No, it's okay.
No, then wish you good luck on the final project, okay? And
Okay.
then we have more. Next week we have one more topic, okay? One more session. We'll talk about the PIC controller, okay?
Okay.
That's it. If no question, that will be it for today, okay?
Okay, sir,
Yeah, question?
I have one question, sir. I'm working for my last final presentation. However, I don't have any physical robot. So I already told you about this.
Yeah, it's
Like,
okay. We
yeah, how-
have other topic like doing modeling or doing okay. So modeling, you come with the idea for modeling of the product, right? Of the robot, right? So
Yes.
what we would look at is more like the gecko thing, the presentation, the visualization. How can you visualize that your motion or something?
Okay.
You have to focus on this one, okay? Using the MapRLive to do it, okay?
Yes, I'm working on it.
That's what we want. Just show me that your system variable being controlled in what condition, and then you perform like this. That would be good enough. But do not just give me one picture, okay?
Yes.
One
Okay.
picture.
No. I will send you the code and how it works.
One picture doesn't
It's
mean
not-
that you work hard, okay? Just give me a list. That's not enough, okay? You need to show your dedication and also really do something in the project, okay? Right? So that
Yes.
is okay. Not everyone has a budget to build a robot. We know, okay? So
Yes.
in the beginning of the term project description, we say it already. Okay, it's okay.
Yes,
You
sir.
do modeling. So any
Yeah.
other question?
Thank you
Yeah,
so much.
which software is good for modulation, for to do the simulation? Which software would be good for to do the simulation?
Usually is a few things you may use. Okay, Gecko is one of them, right? So some other thing like you need a PyLab, okay, or Matplotlib. Okay, this actually is NumPy plus Matplotlib. It's called PyLab, okay, and this is needed. Gecko is something you may need it, okay, and if you put the scientific package, that's also fine, okay. And then if you put TensorFlow, that's also fine. Okay, I don't care. And OpenCV, okay, Open Computer Vision. We introduce it in the control of the vision. Okay, so this one, what you need to do, okay, for the modeling. Let's see. For modeling, you basically need to do end-to-end modeling. What does it mean by end-to-end? Okay, let me tell you what end-to-end really mean in communication and robotics. So let's assume that you have a speech recognition problem, right? So you hear some audio signal, you do A to D conversion, right? You get into system, so you kind of sample it into digital format, right? And you do pattern recognition. So this is ML, right? And then you figure out this is a Mr. Brown, okay, whatever. And you do D to A conversion, and you say Mr. Brown. This would be a typical end-to-end modeling from the source to the sink. Is okay?
Okay. Mm-hmm.
So in a way, your robotics, if you want to do end-to-end modeling, you have to say about your range of your end-to-end, right? Everybody's definition can be different. So if you just say that, okay, minimum, you need to give me from actuator to the robot arm. So you need to give me a set of C dot D, whatever equation, and a certain 3 degree of freedom robot, that's fine, and how it works, how the XYZ work. This is the minimum I need to see, right? And we cover this in class, actually, right? We cover the 6 degree of freedom robot in some of the homework, right? But you need to have a new design. Don't copy the same one. If you have a new design, you go over from scratch one more time. So at least maybe your robot is like extender, rotator, extender, okay? That's fine, I don't care. Whatever robot you come up with, as long as it's different from the 6 degree robot that we have, okay? Then that's already an end-to-end model. If you can do dynamic modeling for the whole motion, car motion, that's even better, but we do not require it. I'm sorry, not saying that we do not require it. We encourage as a minimum of design that you do the system available to the workspace as a minimum. Any additional one are welcome, I should say in this way, okay? Is that okay?
Okay, sir. Thank you.
Any other question?
No, sir, I'm good.
Okay, if not, wish you good luck, okay? Try to
Okay, thank you,
learn
sir.
something.
Thank you so much.
Try to learn something. Okay, see you next time. Bye-bye.
Thank you.
Thank you. Bye bye.